Hello everyone, welcome to Shiwam's classes. In today's lecture, we are going to discuss exercise number 3.3 and problem number 1 to 4. So problem number 1 to 4 is about proving some functions, trigonometric functions to certain numbers. So before getting into the exercise, let's try to understand some of the concepts behind how to solve these problems. Alright, so first of all, we need to understand how to convert degrees and degrees into radian as well. So we might have studied, or you remember that 2 pi is equal to 360 degree. So if you draw this system of Cartesian system, and so you know that from here to here it is 90 degree or pi by 2, from here to here it is 180 degree or pi, from here to here it will be again 270 degree or 3 pi by 2, and when we come to the fourth quadrant, then the values would be 360 degree or 2 pi, right? So that's why 2 pi equals to 360 degree, pi equals to 180 degree, and so on and so forth. So you know that we have to calculate sine pi by 6. So pi by 6 is what? Pi by 6 would be nothing but 180 degree divided by 6, which will be 30 degree. Alright. Similarly, we need to calculate something in pi by 3. So what will be pi by 3? My pi by 3 will be 180 degree by 3, which will be 60 degree. And then finally, what will be my pi by 4? My pi by 4 would be nothing but 180 degree divided by 4, which is 45 degree, right? 4 you have to just divide, right? So as I did 30 degree, 3 6 ja 18, 60, and 4 ja 16, and then 5 4 5s are 20, right? So that's how you get it. Now you also need to know values of sine pi by 6, cos pi by 3, and tan pi by 4. So let's understand what is sine pi by 6. So sine pi by 6 equals to nothing but sine 30 degree, which we have calculated above, and sine 30 degree is 1 by 2, we know that. Similarly, what will be my cos pi by 3? Cos pi by 3 is cos 60 degree, which will be actually equal to again 1 by 2, which is nothing but sine 30 degree. Now we have to calculate tan pi by 4, which is tan 45 degree, which is 1. Now let's put the values over here. So with my LHS, what is my LHS here? Sine square pi by 6 plus cos square pi by 3 minus tan square pi by 4. Now I'll put the values. We have calculated sine pi by 6 is 1 by 2 square, cos pi by 3 is again 1 by 2 square, and tan pi by 4 is 1 square. Alright, this is 1 by 4, 1 square, basically 2 square, 1 by 2 square is 1 by 4, and again 1 by 2 whole square is 1 by 4 minus 1. Now you can actually take LCM. So this will become 1, this will become 1, and this will become 4, which will be minus 2 by 4, which will be minus 1 by 2, which is nothing but RHS. Alright, so you saw what we did over here. We figured out the values of different trigonometric functions at different angles, and then we just put the values back here. So if you don't remember the values of these angles, please go back and then study them thoroughly so that you remember them on your tips, so that the problems become very easy for you to solve. Sure. Can we move to the next problem now? Okay, let's move to the next problem. Alright. Now we have been given here 2 sine square pi by 6 plus cosec square sine pi by 6 and cos square pi by 3. So let's first write down the LHS here. So my LHS is 2 sine square pi by 6 plus cosec square 7 pi by 6 into cos square pi by 3. Alright, so here there is another thing which we need to know. If we remember our exercises or the examples from this chapter, we know that we can reduce bigger angles into the smaller angles. So let's talk about cosec pi 7 pi by 6 separately. Alright, so cosec 7 pi by 6 can be written as cosec pi plus pi by 6 as well. How did we do that? We just divided 7 by 6 and saw that what is the remainder. How do we go by doing this? Is we see what is 6, 1 is just 6 and then 1 is the remainder. So we know that 1 time some number and then plus it will be, so what will be 7 in terms of this is nothing but 6 into 1 plus 1. So and when you are dividing it by 6, so this way you can write 7 by 6, 6 by 6 plus 1 by 6, which is nothing but 1 plus 1 by 6 is what I have done over here. I have reduced 7 pi by 6 to 5 plus pi by 6. And why do we do that? Because we know that some of these angles we can calculate easily when we reduce it to smaller angles, and we can see that pi is from here to here and pi by 6 again will be here. So basically this angle will be in third quadrant, and here this is cosec. So what will happen to cosec? This will become minus cosec and pi by 6, it will become pi by 6. Why it will be minus? Because in this quadrant my tan and cot would be positive and rest of all the entities will be negative. So my cosec pi plus pi by 6 will become minus cosec pi by 6. Now we know the value of pi by 6 when my cosec theta is there, right? We can as well write, as we have seen in the previous example, this could be written as minus of cosec 30 degree, and we know that cosec 30 degree is nothing but 1 upon sine 30 degree as well, if you don't remember directly the value of cosec 30 degree, which will be nothing but 2. Alright, so you can write minus 2. So even if you just remember sine 30 degree, you can derive cosec 30, because cosec 30 would be 1 upon sine 30 degree, and we know 1 upon sine 30 1 upon 1 by 2, which will become 2, right? This is what we have got. Now we have to know the value of sine pi by 6 as well, which we just did. Sine pi by 6 would be sine 30 degree. So if you want to write, you can write it like this also, 2 sine square pi by 6, which will become 30 degree. Why? Because as I said, pi equals to 180 degree. So pi by 6 would be 180 degree by 6, which will be 30 degree. 2 sine square 30 degree plus cosec square 7 pi by 6, we have already found out the value of it, but we'll write it in two steps. It's minus cosec pi by 6. You can write like this, minus of, or let's write it in two steps. Whatever we have done separately, we'll write it over here as well. So we will write it as cosec of pi plus pi by 6, whatever we have done here, and this is whole square, into cos square of pi by 3. Now what will be my pi by 3? Pi by 3 will be, if we do it this way, will be 180 degree by 3, which will be 60 degree, and we know cos square 60 degree will be what? Cos square 60 degree will be 1 by 2 whole square. Now 2 into sine square 30 degree. Now let's write the value of sine square 30 degree. Again it's 1 by 2 whole square plus cosec square pi plus pi by 6. We have already derived the value, which is nothing but minus 2 whole square into 1 by 2 square. So we can write it like this. So now this has become 2 into 1 by 4 plus 4 into 1 by 4, right? This will become 4. So this will be 1 and this will be 1 by 2. So this is 1 plus 1 by 2 plus 1 equals to 3 by 2, which is nothing but RHS. Alright. So all that we had to do was to find out value of sin pi by 6, reduce this entity into a smaller entity and then get the values. Alright. Hope this is clear. So let's move to the next one. Next problem is again finding out some values of these trigonometric functions at various values of angles. So now again, if you look at the mid one, it's like 5 pi by 6. So we should reduce it to some manageable number. So look at cosec 5 pi by 6. Can we write it as cosec of 6 minus 1 into pi by 6? So 5 I have written as 6 minus 1. 5 equals to 6 minus 1. Alright. Now this is nothing but cosec of 6 into pi minus pi by 6. So I have multiplied pi inside. Now this will become my cosec of pi and then it will be minus pi by 6. I divided it separately. So now when you look at this is like pi is from here to here and then it has to move in this direction to pi by 6, and this is again in second quadrant. In second quadrant my sine and cosec both will be positive. So in this quadrant it will be positive, so I can return cosec of pi by 6, which will be nothing but 2. Alright. So why did I reduce it to 6 minus 1 pi by 6 and not like say pi by 2 plus something like this, pi by 2 plus say what else, pi by 2 plus pi by 3 pi 2 pi. Why didn't I write like this 5 pi by 6? I could have written like this as well. Look, and then what would have happened, this cosec pi by this, what would this have become? So in the other way this would have become pi by 2 plus pi by 3. This is nothing but 5 pi by 6, and now I know that this is an odd multiple of pi by 2, so this will cosec will become sec and sec pi by 3, but since it is in second quadrant this will be positive, which is nothing but 2 again. So I could have done it in both ways, but generally it is advisable to have multiples of pi, because then your cosec would or sec would not change. The entity before the angle will not change if you have a multiple of pi beforehand, right? So that is why I was trying to reduce it to pi minus pi by 6, not into this. We could have done it this way as well. This is nothing is wrong with that as well. Alright. So now coming to the LHS of it. What is my LHS? LHS is cot square pi by 6 plus cosec of 5 pi by 6 plus 3 tan square pi by 6. So cot square pi by 6, again just to make it easy, pi by 6 would be 180 degree divided by 6. You could work in radian or degree, whatever is comfortable with you. I find it okay to deal with radians as well, so that is why I did not convert it into degrees, but you could have. So now cot of 30 degree would be root 3 whole square. My cosec 5 pi by 6 I just calculated, it will be 2, and then my 3 tan square pi by 6 would be 3 into tan pi by 6 will be 1 by root 3, and we have to do a square of it. Alright, now root 3 square is 3 plus 2 plus 3 into 1 by 3, root 3 whole square is 3, so 3 cancel out, so we have got 5 plus 1, this is 6, which is nothing but RHS. So here too we should know the value of cot pi by 6, cosec pi by 6, and then tan pi by 6. If we know the values of 3, then we will be able to solve these examples easily. Now coming to the last problem for this video lecture, we have to calculate 2 sin square 3 pi by 4, cos square pi by 4, and sec square pi by 3. So except pi, these two integers, this one is into somewhat different territory. We know values from 0 to 90, but this is more than that, right? So what is 3 pi by 4 if we want to calculate 3 pi by 4? So we know that pi is 180 degree and this is 4, so this will be 45, and this is will be 90 degree, and then plus 45, there will be 135 degree, right? So we don't know the values of 135 degree, but can we write sine of 3 pi by 4, which is nothing but sine of 135 degree, to this sine of 180 degree minus 45 degree. Again, why did I do it? Because this is my multiple of 180 degree, and my sine will not change to cos. We know that if it is a multiple, if it is an odd multiple of 90 degree, then my sine will change to cos, cos will change to sine, and things like that will happen. So this is nothing but sine of 45 degree. We know why, because we know that sine of 180 degree minus theta equals to sine theta. So what will be my sine 45 degree? Sine 45 degree is nothing but 1 upon root 2. Okay. So now let's talk about my LHS. My LHS is 2 sine square 3 pi by 4 plus 2 cos square pi by 4 plus 2 sec square pi by 3. Now my 2 sine square 3 pi by 4 is 2 into 1 by root 2 whole square. Because this is sine square 3 pi by 4, I have calculated sine of 3 pi by 4 plus 2 into, again cos pi by 4 is same way, cos pi by 4 would be 1 by root 2, and that's a whole square, plus 2 sec square pi by 3. So 2 sec square pi by 3 would be what? So sec pi by 3 is what? This is 60 degree, sec is cos, opposite of cos 60 degree, which will be nothing but 2, right? Sec pi by 3 we had already calculated, the value of this will be 2. So we have what we have over here is 2 into 2 square, right? Now we have got 2 into 1 by 2 plus 2 into 1 by 2 plus this will be 8, 2 into 2 into 2 will be 8, isn't it? Now my this becomes 1, this becomes 1, so 8 plus 1 will be 10, which is nothing but RHS. Alright, so yeah, in these 4 examples all we had to do was to know the values of sine 30 degree, cos 30 degree, sine 45 degree, cos 45 degree, tan 30 degree, cot 30 degree, cos 60 degree, and all that, right? So all that we got to do is we got to remember this kind of table which we have. Let me create a table for you. So we had this kind of a table wherein, I hope you remember this table, wherein we have values of 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree, and we have sine, cos, tan. So if you know all these three, then you can just reverse it. And moreover, if you just know a few values, then you will be able to convert all of them. So sine 0 is 0, sine 30 degree is 1 by 2, sine 45 degree is 1 by root 2, sine 60 degree is root 3 by 2, and then 90 degree is 1. And this is just opposite of it. So 1 is over here, this root 3 by 2 would come over here, minus 1 by root 2 would be here, 1 by 2 will come over here, and 0 will come over here. So this is just changing over. If you remember the first row, that would be enough. And then this is the opposite of it. So sine upon cos 0, this is 1 upon root 3, sine upon cos, this is 1, this is root 3, and this is undefined. So if you remember this table, then you will be able to derive everything. Alright, so these 4 problems you could just easily solve it if you know the formulas right. To discuss problem number 5, 6 and 7 of chapter 3, exercise 3.3. In last lectures we had discussed problem 1 to 4, and now we'll start today with problem number 5. So when you look at problem number 5, it starts with finding out the value of sine 75 degree and tan 15 degree. So in such problems, what we need to do is we need to reduce such degrees or such angles to a manageable degrees which we know already. So if you remember from your last classes like 10th, we had calculated values of 0 degree, 30 degree, 40 degree, 60 degree and 90 degree of various trigonometric functions sine, cos, tan, right? So you know the value of sine is sine 0 degree is 0, sine 30 degrees 1 by 2, sine 45 degrees 1 by root 2, and so on and so forth. So if you know values of sine, cos and tan, you know, right, you can actually get the values of cosec theta, sec theta and tan theta, because and cot theta, because they are reciprocals of sine, cos and tan, right? So you can say cosec theta is nothing but 1 upon sine theta, sec theta is nothing but 1 upon cos theta, and cot theta is nothing but 1 upon tan theta. So for each values of 0, 30 or 45 degree, we can get values of these as well. So you just have to remember these values, and we will work with these values now. Okay, so now coming to the first problem, here we have sine 75 degree. We don't know the value of sine 75 degree, but we do know the value of 45 and 30 degree. So what we'll do is we will write 75 degree as 45 degree plus 30 degree. All right. And now when you look at this expression, you know that we have also learned a new formula, which is sine a plus b. Sine a plus b is sine a into cos b plus cos a into sine b, right? So if here this 45 degree becomes a and 30 degree becomes b, then what will this expression become? This expression will become sine 45 degree into cos 30 degree plus cos 45 degree into sine 30 degree. Yeah, you can look at this formula. Now we know the value of sine 45 degree. Sine 45 degree is nothing but 1 upon root 2. We also know the value of cos 30 degree, which is nothing but root 3 by 2. We know the value of cos 45 degree, which is again 1 upon root 2, and sine 30 degree is nothing but 1 by 2. Now you can see the expression here. In the denominator we have 2 square root of 2. So we can take 2 square root 2 as LCM, and what will happen to the numerator is this will become root 3 and this will become plus 1. So this is what the answer would be, root 3 plus 1 divided by 2 root 2. That will be your answer. Let's go to the second part of it, which is tan 15 degree. We'll calculate the value of tan 15 degree. So again, we do not know the value of tan 15 degree, but we do know the value of 45 and 30 degree. So can we write tan 15 degree to tan of 45 degree minus 30 degree. And we also know something, that tan of A minus B is tan of A minus tan of B divided by 1 minus tan A into tan B. This we have already uh, understood in the chapter. So now if you look at this value, if this becomes my A, this becomes my B, the expression becomes tan A minus B, and what I can write over here is tan 45 degree minus tan 30 degree divided by 1 minus tan 45 degree into tan 30 degree. Alright, because the tan 45 degree is tan A, tan 30 degree is tan B, so this is what the expression would become. We also know the value of tan 45 degree, which is 1. We know the value of tan 30 degree, which is 1 upon root 3. We know the value of tan 45 degree, again it's 1 into 1 upon root 3. So now we can take an LCM of root 3 here, right? When we take LCM of root 3, then this will become root 3 and then this will become minus 1, right? And again in the denominator we take square root 3 as LCM, then this will become root 3 minus 1 because this will be multiplied here minus. Okay, so here it is minus and then here it is plus, right? This is tan A minus tan B and this is plus, right? So this is what I shouldn't be making a mistake here. So this is root 3 plus 1. Alright, now root 3 is gone. Now we are left with root 3 minus 1 divided by root 3 plus 1. You have arrived at some value, but generally when we have some prime number, when we have some irrational number like this in the denominator, we try to reduce it to a better value. So what we do, we generally multiply it by a quantity which can make it more like a rational number, right? So what we do is, in such cases we multiply it by root 3 minus 1, whatever be the sign of this, we multiply it by a quantity which is opposite in the sign. So if it had been in root 3 minus 1 in denominator, I would have multiplied with root 3 plus 1 in the numerator and denominator both. So this quantity is nothing but 1, right? If I just strike it out, it will be 1, right? So this entire expression will not change, right? But it will get simplified, right? What will happen is, this is again root 3 minus 1, this is also root 3 minus 1, so this will become root 3 minus 1 whole square, while a denominator will become root 3 plus 1 and root 3 minus 1. This is nothing but, if you look at the expression a plus b into a minus b, and which is nothing but a square minus b square. So in this case what will happen, this will become root 3 square minus 1 square. So now coming to this part, if you can expand it, it's a minus b whole square, so this will be root 3 whole square plus 1 square minus 2 times of root 3, and which will be divided by root 3 square, which is 3, and then there will be minus 1 over here. Now root 3 whole square is 3, then 1 square is 1, and minus 2 root 3 and divided by 2. Now this will become 4 minus 2 root 3 divided by 2. You can take 2 common and then it will become 2 minus root 3 divided by 2. 2 will get cancelled out and then you will be reduced with 2 minus root 3, and which will be your answer. So you can look at here, this is more manageable number than this, right? If we had stopped over here. So that is why whenever we are dealing with an irrational number, we generally try to reduce the denominator by multiplying it by a factor such that it becomes a rational number. This is something which we do generally. Alright, so let's move on to the next problem. The next problem talks about some quantity multiplied by some quantity, and we have to prove that LHS equals to RHS. Alright, so So when you look at this problem closely, what you can see that this quantity pi by 4 minus x is also over here, pi by 4 minus x, and this quantity, if you call it like this is also over here, pi by 4 minus y. So if let's say we assume pi by 4 minus x is a and pi by 4 minus y is b, then the whole expression of LHS will become what? LHS will become cos a into cos b minus sin a into sin b, and we know that this is a formula of cos a plus b, so we can just write cos a plus b. Now put back the values again. So what will happen here is we can put pi by 4 minus x plus pi by 4 minus y. Alright, so why did we do that? So when you look at this expression, you could have understood that this is coming to a formula, and that is why you were just trying to minimize the error by just calling it a and b. So we called it a and b, and then this formula appeared to be very familiar, and that's why we came to this step. Now when you came to this step, now you can see that this and this will get added. So pi by 4 plus pi by 4, when you add both of them, it will become pi by 2, right? Or you just write pi by 4 into 2, this is 2 times this, and then minus x minus y. When this will get cancelled out, then this will be cos of pi by 2 and minus, I'll take common, and then this will become x plus y. And if cos of pi by 2, so we know that cos of pi by 2 minus theta is nothing but sin theta, right? This is also we know, because first of all this is in first quadrant, this pi by 2 minus theta, this pi by 2 minus theta is in first quadrant, and cos is having an odd multiple of pi by 2, so cos will become sin. So then this expression will become sin of x plus y, which is nothing but what we have to do, we have to batches. Alright, so let's move on to the next problem. So next problem is talking about tan pi by 4 plus x, tan pi by 4 minus x, and we have to prove it that it is equal to 1 plus tan x divided by 1 minus tan x whole square. So again, if you are looking closely, you can see that tan pi by 4, if we call it a and call it x as b, then this is nothing but tan a plus b, and the denominator is tan a minus b. So we know the formula of tan a plus b and tan a minus b, right? So we'll again write the formula of tan a minus b here, because we have already written in previous example tan a plus b's formula. So this will be tan a minus tan b divided by 1 plus tan a into tan b. Alright, so let's put that down. First let's write tan pi by 4 plus x divided by tan pi by 4 minus x. Now let's write it as tan a plus tan b. So tan a is tan pi by 4 plus tan b is tan x, and then divided by 1 minus tan a, this is nothing but tan pi by 4, into tan b, which is nothing but tan x, and then again divided by, and then it is tan a minus b, so we'll have to write tan pi by 4 minus tan of x divided by 1 plus tan pi by 4 into tan x. Alright, now the numerator, so we know the value of tan pi by 4. So tan pi by 4 is what? Pi by 4 is nothing but 180 degree by 4, which is 45 degree. So we know the value of tan 45 degree, which is 1. So we'll put 1 plus tan x divided by 1 minus tan x, and then here it will again be 1 minus tan x divided by 1 plus tan x. So when you just simplify it, you can put the numerator as denominator, denominator as numerator. So this will become 1 plus tan x divided by 1 minus tan x, and then this part will go to the top, so it will become 1 plus tan x, and this will come down, which will be 1 minus tan x. So when you look at this expression, this is 1 plus tan x, 1 plus tan x. So this is nothing but 1 plus tan x whole square. And then denominator is 1 minus tan x whole square. So when you reduce it further, this will become 1 plus tan x divided by 1 minus tan x whole square. This is what we have to prove on the right hand side. RHS proved. Alright, so these are the three basic questions we wanted to discuss. If you have any questions, please ask me in the comment section below, and thank you for watching.
We are going to discuss problem number 17, 18 and 19 of exercise 3.3 chapter 3 of class 11 mathematics. So we have already discussed problem number 1 to 16 in previous videos. So you can go ahead and watch those videos and have a look at the solution. So we'll start today's discussion with problem number 17. So as usual, before starting the discussion, we'll try to understand again the concepts behind the problems and try to work out the solution. The first problem is talking about some expression on the left hand side, which is sin 5x plus sin 3x divided by cos 5x plus cos 3x. So we got to prove it to be equal to tan 4x. So when you look at the expression on the left hand side, you just look at the numbers first, and then you can see that there is a number 5x, there is a number 3x, right? And when you sum it up and divide it by 2, you will get, once you sum it up, you will get 8x, right? When you sum it up, and then when you divide it by 2, you will get 4x, right? So it is looking like it is some sort of a formula wherein you have to use c plus d by 2, and we already know that there are two formulas. One is sin c plus sin d, and which is equal to 2 of sin c plus d by 2 into cos of c minus d by 2. This is first formula. And the second formula on the cos side is cos c plus cos d equals to 2 times cos of c plus d by 2 into cos of c minus d by 2, right? So these are two formulas, and by looking at the expression and knowing that the numbers are given in such a way that it will reduce to 4x. So we'll start with the problem now. So let's start with the problem first. So this is my LHS. When you look at my LHS, it is sin 5x plus sin 3x divided by cos 5x plus cos 3x, right? Now when you try to work out using the formula, this will be 2 of sin of c plus d by 2, yeah, this means 5x plus 3x by 2 into cos of 5x minus 3x by 2 divided by 2 of cos of c plus d by 2, which is 5x plus 3x by 2 into cos of 5x minus 3x by 2. So 2 will cancel out, and this is also cos 5x minus 3x by 2. This is also cos 5x minus 3x by 2. So this all will also cancel out, and then the numerator will become sin of, this is 5x plus 3x by 2. This is 8x by 2, which is nothing but 4x, and divided by cos of 5x plus 3x by 2, which is nothing but again 8x by 2, which is 4x. And we know that sin 4x upon cos 4x is nothing but tan of 4x, which is what we had to prove on the right hand side. So this is a straightforward application of sin c plus d, sin c plus sin d formula and cos c plus cos d formula. So this is how you have to apply. You look at the left hand side, try to see what is the number given on the left hand side and what's the number on the right hand side, and then start working out the problem. So let's go to the next problem, problem number 18. Here too you can see that the expression is sin x minus sin y, and divided by cos x plus cos y. So as we were doing in the earlier example, we got to know these formulas all right. Sin c minus sin d. What would be my sin c minus sin d? It would be nothing but 2 of cos. Here sign changes to cos if there is a negative over here. This is how you remember. If there is a negative sign over here, the sign will change to cos, and that will be c plus d by 2. So whatever c plus d by 2, c and d plus, so whatever with expression in summation will have cos term to it, and sine will be having c minus d by 2. Similarly, cos c plus cos d we have already done in the previous example, which is nothing but 2 of cos c plus d by 2 into cos of c minus d by 2. Alright, so you have to just use the formula. Let's use the formula here. So sin x minus sin y divided by cos x plus cos y. Now sin x minus sin y is 2 of cos of x minus x plus y by 2 into sin of x minus y by 2. This is what we have done over here. Sin c minus sin d. This is the formula. And now this is 2 of cos of x plus y by 2 into cos of x minus y by 2. Now my this 2 gets cancelled out, cos gets cancelled out. So we are left with sin of x minus y by 2 divided by cos of x minus y by 2, which is nothing but tan of x minus y by 2, because the theta inside it is same x minus y by 2, here it is also x minus y by 2. So which is nothing but the RHS which you had to do. So these are again straightforward application of formula, and you could see that on the right hand side the expression is given in such a way that while you try to solve on the left hand side you will be reduced with the same thing. Alright. So in such application or such question, you see that whatever is the complicated question or the equation, you try to solve it to reduce it to the simpler one. And in this case our left hand side was pretty complicated, and on the right hand side it was very simple, right? So this is what we had to start with. We had to start with the complicated part and try to reduce it to much more manageable form. Alright, so let's move on to the next problem, which is problem number 19. And here again, it's again application of the formula. It's sin c plus sin d divided by cos c plus cos d. And as you could see over here as well, there is 1x and then there is a 3x. So when you add it and divide it by 2, so that term will remain and rest of the term will cancel out. So let's use the formula in a straightforward manner and get the result out here. Sin x plus sin 3x divided by cos x plus cos 3x. So this is the formula for sin c plus sin d. So I'll get 2 into sin c plus d by 2, which is x plus 3x by 2 into cos of x minus 3x by 2 and divided by 2 of cos of x plus 3x by 2 into cos of x minus 3x by 2. So my 2 cancels out, cos x minus 3x by 2, cos x minus 3x by 2 cancels out. So we are left with sin of x plus 3x is 4x, 4x divided by 2 is 2x, and this same way x plus 3x is 4x divided by 2 is 2x. This is what 2x. So sin 2x upon cos 2x is nothing but tan 2x, right? So here as well we use the formula sin c plus sin d equals to nothing but 2 of sin c plus d by 2 into cos of c plus d by 2, and cos of c plus cos of d equals to 2 of cos of c plus d by 2 into cos of c minus d by 2. Alright. So when we look at such expressions, we have to be aware that this is gonna be the simplification of the equation, and to reduce it to the much more simpler form on the right hand side. Uh, you should not get confused by saying 3x and try to use the formula of that. You could actually do that as well. There is nothing wrong, but I mean it's much easier to use it this way. So alternative way to do it is, if you remember the formula of sin 3x, right? If you know the formula of sin 3x, you could directly put the value over here and then try to solve it as well. Then in that case, what you got to do is, you'll have to solve the left hand side as well as on the right hand side. We are going to discuss problem number 8, 9 and 10. In previous lectures, we have already discussed from problem number 1 to 7. So just like in any other lecture, we'll first try to discuss the concepts and then try to solve the problem. So the very first concept here is again that we need to remember that in which quadrant which trigonometric functions are positive. So we know that everything is positive in this quadrant. My sine and cosec are positive in this quadrant. My tan and cot are positive in my third quadrant, and my cos and sec are positive in my fourth quadrant. So this is the very first thing. The second thing is, we need to know that any trigonometric function, if multiplied by an odd multiple of pi by 2, odd multiple of pi by 2 plus or minus theta, will change to sine, will change to cos, cos will change to sine, and then depending on in which quadrant this angle is going to lie, we'll have to come up with the sign. So I'm just going to write plus and minus of cos theta. So here if I have to write it in a better fashion, so I will write it is gonna be plus or minus of cos theta depending on which quadrant it is gonna lie. Same is the case with cos, odd multiple of pi by 2 plus of minus theta will become plus or minus of sine theta depending on the sign, and then we have to look at in which quadrant it is gonna lie, but cos will change to sine. Same thing, tan will change to cot, and cot will change to tan, sec will change to cosec, and cosec will change to sec. So this if odd multiple of pi by 2 is there. But if it is even multiple of pi by 2, then sine will remain sine, cos will remain cos, and all that. The third thing which we need to know is that need to remember again is that pi equals to 180 degree, and this implies pi by 2 equals to 90 degree, and so on and so forth. So yeah, now with this in mind, let's look at this problem again and look at this LHS. My LHS is cos of pi plus x into cos of minus x divided by sine of pi minus x into cos of pi by 2 plus x. So cos of pi plus x, when you look at cos of pi plus x, so pi is from here to here, and then x is further here. So this is gonna be my pi, this is gonna be my x. Pi plus x is going to be in my third quadrant, and this is pi is an even multiple of pi by 2, so cos will remain cos. So this will become cos x, and since it's gonna be in the third quadrant, then this will become my minus. Now cos of minus theta, cos of minus theta or cos of minus x is this. We have to go in this direction. The angle is negative in this other direction, angle is positive in this direction, positive direction, negative direction. So cos of minus x, this is gonna be in fourth quadrant, and cos is positive in this quadrant. So cos of minus x is gonna be cos x. Now sine of pi minus x, look at sine of pi minus x. So pi is going to be from here to here, and if you look at a little bit of x, which is going in the other direction, so it's going to be in the second quadrant. So sine of pi minus x will become sin x, because pi is my even multiple of pi by 2. So this will become sin x. Now look at cos pi by 2 plus x. Cos pi by 2 plus x, where will cos pi by 2 plus x will lie? So this is going to be my pi by 2, this is going to be my x, right? So this is going to be in my second quadrant, and pi by 2 is an odd multiple of pi by 2. 1 into pi by 2, pi by 2 is 1 into pi by 2, which is an odd multiple. So cos will change to sine, so sine it will be, and then cos is actually negative in the second quadrant, so it will be minus of sine x. Alright, so this is what it is. Now look at this expression, this is minus and this is minus, this will become plus. This is cos square x divided by sine square x. There are two x's, so this is gonna be cot square x, which is nothing but RHS. Alright, now let's move on to the second problem and see what is being asked over here. So in this question, LHS is given as cos of 3 pi by 2 plus x into cos of 2 pi plus x into cot of 3 pi by 2 minus x plus cot of 2 pi plus x. Alright, now when you look at this problem, cos an odd multiple of pi by 2, so cos will change to sine, and 3 pi by 2 is gonna be 3 pi by 2 is where 1 pi by 2, 2 pi by 2, 3 pi by 2 plus x. So this is gonna be fourth quadrant. So cos will change to sine, and the sine of this will remain positive. So plus of sine x, we don't have to write. Now cos 2 pi plus x. 2 pi is what? 2 pi is 4 into pi by 2, which is an even multiple. So cos will remain as cos, and this 2 pi by x. So 1, this is 1 pi, this is 2 pi, and then this is x. Right? This is pi, this is 2 pi, this is x. So this is gonna be again in the first quadrant. So cos of 2 pi plus x is nothing but cos of x. Right? Now multiply and look at cot 3 pi by 2 minus x. Cot, and this 3 pi by 2 is odd multiple of pi by 2, so cot will change to tan. That is one thing which we have to write, tan of x, and 3 pi by 2 minus x. So again, just when you look at this 3 pi by 2 minus x, this is pi by 2, this is 2 pi by 2, this is 3 pi by 2, and then minus x. So this is what is gonna be my angle, and from here to here it is gonna be 3 pi by 2 minus x, and we have to look at, this is gonna be third quadrant where cot is gonna be positive. So yeah, this is gonna be positive. Now plus cot of 2 pi plus x. Again, as I did in the previous one, 2 pi is like going the full circle and then coming further up. So cot will remain as cot because 2 pi, again as I said, it is even multiple of pi by 2. So cot will remain as cot of x, right? Now look at this. This is sin x into cos x, and this is tan x can be written as sin x by cos x, and cot x can be written as cos x by sin x. Alright. Why did we do it? Because we were saying this and we have to cancel it out, and on the right hand side we are just seeing something like 1. So we know that this will cancel out. So that is why we reduced tan x to sin x by cos x, and cot x to cos x by sin x. So now look at this, sin x into cos x, and this is gonna be my LCM, cos x into sin x. I can take cos x into sin x as LCM. Now cos x will cancel out, so this will become sin x into sin x, and the other one will become, this will become cos x into cos x. Now this sin x cos x will get cancelled out, and this will become sin square x plus cos square x, and we know that sin square x plus cos square is nothing but 1. So this is what we had to prove on the right hand side. So it is proved. Let's go on to the next problem. Alright, so this is my next problem and the last problem of the day. So this is my LHS. This is sine of n plus 1 into x into sine of n plus 2 into x plus cos of n plus 1 into x into cos of n plus 2 into x. Alright, this is what has been given to us. So now this is looking like this is repeating, n plus 1x is here, n plus 1x is here, n plus 2x is here, n plus 2x is here. So let's assume, let's assume n plus 1 into x is nothing but a and n plus 2 into x is nothing but b. So let's see what this LHS becomes. This will become sine of a into sine of b plus cos of a, which is nothing but cos of a minus b. So now let's put back the value. This is the formula of cos a minus b. So let's put back the value. Now n plus 1 into x minus n plus 2 into x. Let's open it up. Cos of nx plus x minus nx minus 2x. nx gets cancelled out. Minus 2x plus x. So this is cos of minus x, and we know that cos of minus x is nothing but cos of x, so which is nothing but RHS. Yeah, this is what we have to prove. So now we are done with problem number 8, 9 and 10. We are going to discuss problem number 11, 12 and 13 from chapter 3 and exercise 3.3. We have already discussed problem number 1 to 10 in previous videos. Please go ahead and watch these videos. And in today's lecture, we'll start with problem number 11. And just like any other lecture, we'll first try to understand the concept behind the problem and then try to solve the problem. So now onwards, the problems are mostly formula based, and we got to remember the formulas which we had derived in the previous section. So the very first problem here, the 11th problem, talks about something in terms of cos of some angle minus cos of some angle. So we know there is a formula which we had derived wherein we had cos c minus cos d, and we would have minus 2 of sine c plus d by 2 into sine c minus d by 2 for that. Alright, so you can see here this formula which I was talking about. This is basically, this formula is cos theta minus cos of phi equals to minus 2 of sine theta plus phi into sine theta minus phi by 2. So this is what we are discussing here. I am writing in terms of cos c minus cos d. So if you assume 3 pi by 4 plus x to be c and 3 pi by 4 minus x to be d, your LHS would remain. So if you are assuming, your LHS will become cos c minus cos d, and then this will reduce to what? Minus of 2 of sine of c plus d by 2 into sine of c minus d by 2. If I put back the values over here, what will I get? Minus 2 of sine of c is 3 pi by 4 plus x, alright, and your d is what? Your d is minus 3 pi by 4 minus x, so plus of 3 pi by 4, and then you have to say minus of x, and then whole thing will be divided by 2, alright, because this is your c, this is your d, right? This is your c and this is your d. This is what we had done now. And now if you multiply again with this sine c minus d by 2, so what is your c? Again 3 pi by 4 plus x, alright, minus what you got here is 3 pi by 4 minus x, so you will put 3 pi by 4, and then minus of x is there, and then there is another minus sign, so this will become plus of x, alright, divided by 2. Now when you look at this expression, 2 of sine of this 3 pi by 4 plus x, and then there is minus x, so this x and this x will cancel out, and here 3 pi by 4, 3 pi by 4 will cancel out. So here you will be left with 1 3 pi by 4 here, 2 3 pi by 4. So you will write 2 into 3 pi by 4, and whole thing is divided by 2, so I am writing it 1 by 2. Similarly on this side I am writing sine of, this is 1x, there is 1x, so there is 2x over here, 2x divided by 2, so 2 cancels out, 2 cancel out, so we are left with minus 2 of sine of 3 pi by 4, alright, into sine of x, Now, just like previous examples, can we write 3 pi by 4 as pi minus pi by 4? Why? Because if you subtract this from pi, then you will get 4 pi minus pi divided by 4 row, right? So, we'll get minus 2 of sine of pi minus pi by 4 into sine of x. Another thing to note here is when we are doing this is my pi from here to here, and I am going back into this direction just because there is minus pi by 4, right? So this is my 3 pi by 4 from here to here, this is what it was, 3 pi by 4. Now this is gonna be second quadrant where my sign is positive, so this will come to minus 2 of sine of pi by 4. This will be positive, sine will be positive because sine is positive in second quadrant, alright, into sine x. Now we also know the value of sine pi by 4, isn't it? So if we know the values of sine pi by 4, we get what? So we know the values of sine pi by 4, right? So we'll write minus 2 of sine pi by 4 is nothing but 1 upon root 2 into sine of x. This will go, and then here it will be root 2, then we will be left with minus root 2 of sin x, and this is what probably we have to prove on the right hand side, yes, minus root 2 of sin of x. So we will write this equals to RHS, and this is proved. So in this particular example we have to remember the formula, this cos c minus cos j, and this how to reduce 3 pi by 4 to pi by 4, and then it is going to be in second quadrant. So there are three concepts, one being this formula, second being this thing, and third being you knowing that sin theta in second quadrant is going to be positive. Alright, let's move to the next question. So my next question talks about sin square 6x minus sin square 4x. Again you got to know some formulas over here which we had derived. So if you remember, cos 2x was nothing but 2 times cos square x minus 1, or it was cos square x minus sin square x, or it was 1 minus 2 sin square x. So cos 2x had all these ways of writing. So what we can write here is 2 sin square x is nothing but 1 minus cos 2x, or we can write sin square x equals to nothing but 1 minus cos 2x by 2. We can write it either way, right? So now look at the left hand side in this problem. Your left hand side is sin square 6x minus sin square 4x. What if we multiply it by 2 and divide it by 2? So I am just dividing it by 2 and writing like 2 of sin square 6x minus 2 of sin square 4x. Now looking at the formula on the right side, we have just got this 2 sin square x is nothing but 1 minus cos 2x. So 2 sin square 6x will be what? So instead of x, we'll put x equals to 6x, for example. Then what we will be getting here is 2 sin square 6x equals to 1 minus cos of 2 into 6x will be 12x. So 1 minus cos 12x, right? So let's put that over here. We write 1 minus cos of 12x. And similarly, minus 2 of sin square 4x can be written as 1 minus cos of 8x. So all you got to do is you have to remember whatever be the theta over here or angle over here, that will double. So 6x doubles to 12x, 4x doubles to 8x, right? Now let's open the braces. So what will happen is if you open the brackets, it will become 1 minus cos 12x minus of 1 plus cos of 8x. Alright, so your minus and minus 1 will cancel out, and you will be left with here 1 by 2 into cos of 8x in minus cos of 12x. So now you got to know the formula of cos c minus cos d, right? Cos c minus cos d, which is nothing but what? 1 by 2 into minus 2 times sine of c plus d by 2, which is nothing but 8x plus 12x by 2 into sine of c minus d by 2, 8x minus 12x by 2. So what did we write over here? We just wrote cos c minus cos d equals to nothing but minus 2 of sin c plus d by 2 into sin c minus d by 2, which we did in the last example as well. So now when you come over here, what we will get is this 2 cancels out, and then you are left with minus of sine. This 12 and 8 becomes 20, 20 divided by 2 will become 10x into sine of this 8x minus 12x will become minus 4x divided by 2 will be minus 2x, right? So I am just writing here just for you to know 8 plus 12x, 8x plus 12x by 2 is again 20x by 2 which is equal to 10x, and 8x minus 12x by 2 equals to minus 4x divided by 2, which is nothing but minus of 2x. So this is what it is, and we know that sine of minus x is nothing but minus sine x. So we'll take that out and then put it as plus minus minus plus. So this will become sine of 10x into sine of 2x. And if you look at the expression, this is what we had to prove on the right hand side. So this is what is my RHS. If you want to rearrange it, you can write it like sine of 2x into sine of 10x, which is nothing but what we have on the right hand side. So this is also proved. So here again, if you look at the concepts, you know that there is one formula you need to know what is cos 2x in terms of sin square x. You also need to know the formula for cos c minus cos d. So these two things, if you know, you will be able to solve this problem. So this is the first thing, and this is probably a second thing. This is all you got to remember. Alright, now moving on to the third question for the day, and that will be your 13th question. So this is again going to be using the same principle which we discussed in the last example. So what did we say? We said that 2 cos square x is equals to 1 plus cos 2x. So this is what we are going to use over here, and let's use our left hand side again. So our left hand side is cos square 2x minus cos square 6x. So again we multiply it by 2 and divide it by 2. So it will not matter because because the 2 will cancel out. So 2 cos square 2x minus 2 cos square 6x, right? This equals to 1 by 2 into, now 2 cos square 2x becomes what? It will become 1 plus cos 4x, right? Why? Because when there is 1x over here, this becomes 2x, because there is 2x here, that will become 4x. Similarly, this is 6x, this will become 12x, this will be 1 plus cos 12x. Now this 1 and 1 cancels out. Now again we are left with 1 by 2 into cos of 4x minus cos of 12x. Again this is the formula for cos c minus cos d as we did earlier. So this is 1 by 2 into 2 times not 2 times, this is minus 2 times sine of c plus d by 2, 4x plus 12x by 2 into sine of c minus d by 2, 4x minus 12x by 2. Right, what did we write again? Just to reiterate the point, cos c minus cos d is nothing but minus 2 times sine of c plus d by 2 into sine of c minus d by 2. This is what it is. Alright. Now my 2 cancels out and I'm left with minus of Sine of 4x plus 12x will become 16x and divided by 2 will become 8x, and this 4x minus 12x becomes minus 8x divided by 2 becomes minus 4x. So sine of minus 4x. Now take the sine minus out because sine of minus x is equals to sine x. So minus and minus will become plus, and I can write this as sine 4x into sine 8x, which is nothing but your RHS, and this is what is proved. So in all three problems you could see that we are using this formula cos C minus cos D. In previous problem we used cos 2x formula in terms of sin x. Here we are making use of cos 2x formula in terms of cos x. Alright. So these formulas you need to remember. You can as well derive it, but if you remember these formulas, then your problem solving will become much easier. Alright. So this is all we have to discuss in today's lecture. If you have any questions, please ask me in the comment section below, and I'll be happy to answer your questions. Thank you so much for watching this. We are going to discuss problem number 14, 15, 16 of chapter 3 and exercise 3.3. We have already discussed problem number 1 to 13 in previous lectures, and you can watch those videos which are given in my playlist. Now in today's video, we'll start with the problem number 14. But as usual, first we'll start with the concept first and then try to solve the problem, right? So let's try to understand the problem here. So there is something given on the left hand side and there is something given on the right hand side. So we have to prove what is on the left hand side is equal to the right hand side. Now before jumping into the solution, let's try to understand what is given on the left hand side and is there any clue which we get from the right hand side. So when you look at the left hand side, you see sine 4x over here, and then also you see there is there's a 2 multiplied here. So this is one thing which we need to observe, and then on the right hand side you also can see that there is a sine 4x over here, right? So looks like sine 4x has to be retained in while we are trying to calculate whatever we are trying to calculate. All right, and moreover we need to remember some formulas. So for example, we need to remember what is my sine C plus sine D. Alright, so this will be nothing but your 2 of sine C plus D by 2 into cos of C minus D by 2, and if it is sine C minus D, just remember, then it is gonna be your 2 of cos C plus D by 2 into sine C minus D by 2. Alright, so now once we have understood some formulas, why did we do that? Because we can see some sine over here. There is nothing like sine or cos, and then if I am assuming this to be 2x to be C and this 6x to be D, then there is something which is appearing over here. So that is why I had to remember the formula, this formula. Alright, so now let's start with the exercise, and let's start with this problem first. Alright, so I'm just putting a line over here so that we can separate it out. So let me take my left hand side. My left hand side is having sine 2x plus 2 sine 4x plus sine 6x. Alright, now as I said, there is a 2 hanging in over here. So we'll just keep it aside and then try to work with something which is already there. And why do we do it is because also you see that, see, if I know this is 2x to be my, if let's assume 2x equals to C and 6x equals to D, then what we can see, C plus D by 2 will be 4x, right? C plus D by 2, what will be my C plus D by 2? You can see this will be 8x by 2, which is nothing but 4x. So I am getting some expression with sine 4x, right? And that is why I want to club this and this together. Alright, so let's club this together and then try to work with this. Sine 2x plus sine 6x plus 2 sine 4x. Alright, so let's see on the next step. Sine 2x plus sine 6x, going by this formula, it will be 2 times sine of 2x plus 6x by 2 into cos of
2x minus 6x by 2 and then again plus 2 sine 4x, right? Now what we are left with here is 2 of sine of 4x, it's 8x by 2, this is nothing but 4x, and this is what cos of minus 4x by 2, which is cos of minus 2x. So let's write cos of minus 2x, and then we have 2 of sine 4x. What if I take out 2 sine 4x as common? So I took out sine 4x as common, and cos of minus 2x would be nothing but cos 2x, right? And cos 2x plus 1. So we also know, right, cos 2x is what? Cos 2x is nothing but 2 cos square x minus 1. So 1 plus cos 2x would be what? It will be nothing but 2 cos square x, right? So let's put that back over here, and then we'll get 2 of sine of 4x into 2 of cos square x, which is nothing but 4 of cos square x into sin x, sin 4x, right? So we multiplied 2 by 2 and then we got 4, and then cos square x I put in the beginning, and then sin 4x, which is what we had to prove on the right hand side. So again, just looking back at the question, we have to see that how do you reduce this expression to something which we want to prove on the right hand side. So I could have actually taken sin 2x and then worked with sin 4x. I could have just made 2 sin 4x as 1 sin 4x plus sin 4x, right? But that wouldn't have solved my problem probably, and it would have made it complicated. Then we'll have to solve the right hand side and then come to the same thing, right? You can do it either way, but this way it is much simpler. So what I'm saying, in the other way of doing it, let's look at that as well, so that there is no confusion. All right, so what I'm saying is, see, instead of this way, alternative method is alternative, right? Alternative method. What is the alternative? So I could have written sin 2x, and instead of 2 sin 4x I could have written 1 sin 4x over here, and plus another sin 4x over here, and then plus sin 6x, and again use sin c plus sin d formula separately, right? So let's see what this expression would become. So this will become 2 of sin 2x plus 4x by 2 into cos of 2x minus 4x by 2, and this will become plus 2 of sine of 4x plus 6x by 2 into sine of cos of 4x minus 6x by 2. Alright, so further down it would have become 2 of sine of 2x plus 4x by 2 is sine 3x into 2x minus 4x by 2 is cos of minus x, and this would have become 2 of sine of 5x into cos of again of minus x. So we would have to take again 2 of cos of minus x common, and would have left with sine of 3x plus sine of 5x. Alright, now I can write 2 of cos of minus x is 2 cos x. Now again this sin c plus sin d I could have written as 2 into sine of 3x plus 5x by 2 into cos of 3x minus 5x by 2. Alright, so now we are left with 4 of cos of x. I took out 2 outside, and this is like sine of 3x plus 5x by 2 is sine of 4x into cos of 3x minus 5x again cos of minus x. Alright, now in this next step we are left with 4 of cos square x, because cos of minus x is again cos x into sine of 4x. Alright, so in the other way around as well you could have come to the same solution. It's just that By observation, you could have just reduced its problem into a much simpler problem, right? So in this case, you had to do it this thing twice, wherein you could have done it in one step itself, right? So I'm not saying the other was very difficult, but it's just that you can just observe what is that you need to prove on the right hand side and then work with the problem. All right, let's move on to the next problem. What is my next problem? So my next problem is saying cot of 4x and then sine, there is a bracket and sine of 5x plus sine of 3x is equal to cot of x into sine of 5x minus sine of 3x. So now again working with this kind of a problem wherein you have a complicated equation on the left hand side and a complicated one on the right hand side. The easier approach is to solve left hand side and right hand side separately and bring it to some stage and then make sure that left hand side is equal to right hand side. So let's try to understand what do we do in this what do we do in such cases, right? So let's see. So what I'll do is I will solve left hand side first. The left hand side is cot of 4x sine of 5x plus sine of 3x, right? We just said cot of 4x into sine of c plus sine of d is nothing but 2 into sine of c plus d by 2, 5x plus 3x by 2 into cos of 5x minus 3x by 2. Alright, now if this is cot of 4x into 2 of sine of, this is 5x plus 3x by 2 which is 8x by 2 which is nothing but 4x into cos of 5x minus 3x by 2 which is 2x by 2 which is cos x. Now can I write cot 4x as cos of 4x divided by sine of 4x, and can I write 2 of sine 4x as such and into cos x, and now can I cancel this or this. So now on this side we are left with 2 of cos x into cos of 4x, right? And we'll leave this expression like this. All right, and then we'll work with the right hand side. So what is my right hand side? Well, my right hand side is cot x into sine of 5x minus sine of 3x. So my cot of x is cot of x, and this is my sin c minus sin d. So I had written the formula sin c minus sin d, then this formula is 2 of cos c plus d by 2. This is cos of 5x plus 3x by 2 into sine of 5x minus 3x by 2. Alright, so now this is cot x and this is 2 of cos of 5x plus 3x by 2 is nothing but 8x by 2 which is nothing but 4x, and this is 5x minus 3x by 2 which is 2x by 2 which is nothing but sin x. Now can I write cot x as cos x by sin x and bring this sin x over here and then write 2 cos 4x. Can I also cancel this cos x sin x sin x? So now we are left with 2 of cos x into cos of 4x. So by comparing left hand and right hand side, can I write LHS equals to, right? So here left hand side is equals to right hand side. So you see in this problem, I could see on the left hand side also there is something very complicated. On the right hand side also there is something very complicated. So in such scenarios, you should try to reduce it into much manageable form, which is like this: 2 cos x into cos 4x, and work with the right hand side and also try to reduce it to a much manageable form, right? You can compare this with the previous example wherein you see on the left hand side there is something little complicated, but rather on the right hand side there is some multiplication which is not looking so complicated. So we just work with the left hand side, while in this problem we have to work with the left hand side and the right hand side both. All right, yeah, now let's move on to the next problem. So my next problem is this: it's saying cos of 9x minus cos of 5x divided by sine of 17x minus sine of 3x. So here on the left hand side it's much more complicated than right hand side, so let's work with the left hand side and see where do we land. So let's work with the left hand side first. Let's write LHS. What is my LHS? Cos of 9x minus cos of 5x divided by sine of 17x minus sine of 3x. In such a scenario, what we should do is we just use the formula. This is cos c minus cos t, which is nothing but 2 of sine of, so this will be minus 2 of sine of c plus d by 2, so 9x plus 5x by 2, so 9x plus 5x by 2 into sine of c minus d by 2, which is 9x minus 5x by 2. Now this is sine c minus sine d. So again the formula for this is 2 of cos of 17x plus 3x by 2 sec sine c cos c plus d by 2 into sine of c minus d by 2 17x minus 3x by 2. Alright. Now we can cancel out 2 and 2, and so 9x plus 5x by 2, 9 5 14 by 2 is 7x. So this will be sine of 7x when negative remains here into sine of 9x minus 5x, 9x minus 5x is 4x, 4x by 2 is 2x, so sine of 2x divided by, this is cos of 17 plus 3 is 20, 20 by 2 is 10, so cos of 10x into 17 minus 3 is 14, 14 by 2 is 7, so sine of 7x. So sine of 7x it gets cancelled out, so we are left with minus of sine of 2x divided by cos of 10x, which is what we had to prove on the right hand side. So this is a much simpler problem wherein you had to just apply the formula. When you see some expression like cos c minus cos d or sin c minus sin d, you try to work with them rather than working from the right hand side, wherein you had to convert sin 2x into this, which was much more difficult than converting left hand side to the right hand side. Alright, hope the concepts are clear. If you have any questions, please ask me in the comment section below and I'll be happy to answer. Thank you for watching this video.
We are going to discuss problem number 17, 18 and 19 of exercise 3.3 chapter 3 of class 11 mathematics. So we have already discussed problem number 1 to 16 in previous videos. So you can go ahead and watch those videos and have a look at the solution. So we'll start today's discussion with problem number 17. So as usual, before starting the discussion, we'll try to understand again the concepts behind the problems and try to work out the solution. The first problem is talking about some expression on the left hand side, which is sin 5x plus sin 3x divided by cos 5x plus cos 3x. So we got to prove it to be equal to tan 4x. So when you look at the expression on the left hand side, you just look at the numbers first, and then you can see that there is a number 5x, there is a number 3x, right? And when you sum it up and divide it by 2, you will get, once you sum it up, you will get 8x, right? When you sum it up, and then when you divide it by 2, you will get 4x, right? So it is looking like it is some sort of a formula wherein you have to use c plus d by 2, and we already know that there are two formulas. One is sin c plus sin d, and which is equal to 2 of sin c plus d by 2 into cos of c minus d by 2. This is first formula. And the second formula on the cos side is cos c plus cos d equals to 2 times cos of c plus d by 2 into cos of c minus d by 2, right? So these are two formulas, and by looking at the expression and knowing that the numbers are given in such a way that it will reduce to 4x. So we'll start with the problem now. So let's start with the problem first. So this is my LHS. When you look at my LHS, it is sin 5x plus sin 3x divided by cos 5x plus cos 3x. Right? Now, when you try to work out using the formula, this will be 2 of sine of c plus d by 2. Yeah, this means 5x plus 3x by 2 into cos of 5x minus 3x by 2 divided by 2 of cos of c plus d by 2, which is 5x plus 3x by 2 into cos of 5x minus 3x by 2. So 2 will cancel out, and this is also cos 5x minus 3x by 2. This is also cos 5x minus 3x by 2. So this all will also cancel out, and then the numerator will become sine of this is 5x plus 3x by 2. This is 8x by 2, which is nothing but 4x, and divided by cos of 5x plus 3x by 2, which is nothing but again 8x by 2, which is 4x. And we know that sin 4x upon cos 4x is nothing but tan of 4x, which is what we had to prove on the right hand side. So this is a straightforward application of sin c plus d sin c plus sin d formula and cos c plus cos d formula. So this is how you have to apply. You look at the left hand side, try to see what is the number given on the left hand side and what's the number on the right hand side, and then start working out the problem. So let's go to the next problem, problem number 18. Here too you can see that the expression is sin x minus sin y and divided by cos x plus cos y. So as we were doing in the earlier example, we got to know these formulas all right. Sin c minus sin d. What would be my sin c minus sin d? It would be nothing but 2 of cos. Here sin changes to cos if there is a negative over here. This is how you remember. If there is a negative sign over here, the sign will change to cos, and that will be c plus d by 2. So whatever c plus d by 2, c and d plus, so whatever with expression in summation will have cos term to it, and sin will be having c minus d by 2. Similarly, cos c plus cos d we have already done in the previous example, which is nothing but 2 of cos c plus d by 2 into cos of c minus d by 2. Alright, so you have to just use the formula. Let's use the formula here. So sin x minus sin y divided by cos x plus cos y. Now sin x minus sin y is 2 of cos of x minus x plus y by 2 into sin of x minus y by 2. This is what we have done over here. Sin c minus sin d. This is the formula. And now this is 2 of cos of x plus y by 2 into cos of x minus y by 2. Now by this 2 gets cancelled out, cos gets cancelled out. So we are left with sin of x minus y by 2 divided by cos of x minus y by 2, which is nothing but tan of x minus y by 2, because the theta inside it is same x minus y by 2, here it is also x minus y by 2. So which is nothing but the RHS which you had to do. So these are again straightforward application of formula, and you could see that on the right hand side the expression is given in such a way that while you try to solve on the left hand side you will be reduced with the same thing. Alright. So in such application or such question, you see that whatever is the complicated question or the equation, you try to solve it to reduce it to the simpler one. And in this case our left hand side was pretty complicated, and on the right hand side it was very simple, right? So this is what we had to start with. We had to start with the complicated part and try to reduce it to much more manageable form. Alright, so let's move on to the next problem, which is problem number 19. And here again, it's again application of the formula. It's sin c plus sin d divided by cos c plus cos d. And as you could see over here as well, there is 1x and then there is a 3x. So when you add it and divide it by 2, so that term will remain and rest of the term will cancel out. So let's use the formula in a straightforward manner and get the result out here. Sin x plus sin 3x divided by cos x plus cos 3x. So this is the formula for sin c plus sin d. So I'll get 2 into sin c plus d by 2, which is x plus 3x by 2, into cos of x minus 3x by 2, and divided by 2 of cos of x plus 3x by 2 into cos of x minus 3x by 2. So my 2 cancels out, cos x minus 3x by 2, cos x minus 3x by 2 cancels out. So we are left with sin of x plus 3x is 4x, 4x divided by 2 is 2x, and this same way x plus 3x is 4x divided by 2 is 2x. This is what 2x. So sin 2x upon cos 2x is nothing but tan 2x, right? So here as well we use the formula sin c plus sin d equals to nothing but 2 of sin c plus d by 2 into cos of c plus d by 2, and cos of c plus cos of d equals to 2 of cos of c plus d by 2 into cos of c minus d by 2. Alright. So when we look at such expressions, we have to be aware that this is gonna be the simplification of the equation, and to reduce it to the much more simpler form on the right hand side. You should not get confused by saying 3x and try to use the formula of that. You could actually do that as well. There is nothing wrong, but I mean it's much easier to use it this way. So alternative way to do it is, if you remember the formula of sin 3x, right? If you know the formula of sin 3x, you could directly put the value over here and then try to solve it as well. Then in that case, what you got to do is, you'll have to solve the left hand side as well as on the right hand side. We are going to discuss problem number 20, 21 and 22 of chapter 3 and exercise 3.3. In earlier videos, we have already discussed from problem number 1 to 19. Please watch my previous videos to have a look at all those problems being solved. So we'll start with the first problem today, and as usual, first we'll try to understand the concept behind every problem and try to solve these problems. So the very first problem is having some expression on the left hand side, and we need to prove it to be equal to 2 sin x. So what we got to look at is again what are the things which are being available to us. Alright, here you have got something in sin x and then something in sin 3x, and in the bottom side you are getting something also in sin square x minus cos square x. This is looking like an expression we already know. So first of all, let's understand the expression. So if you remember, cos 2x is equals to cos square x minus sin square x. This is just the opposite of that, as in, like, if you take minus common, then it will be sin square x minus cos square x. Alright. So can we write this expression as minus of cos 2x? I think we can, right? So this is something which we will do. On whatever we are having here, can we again look at it and then understand what is the expression over here? So it is looking like sin c minus sin d's formula, and we know this is equal to nothing but 2 of cos c plus d by 2 into sin of c minus d by 2. So when you look at this one, if you add x and 3x and divide it by 2, this will also come out to be cos 2x, right? So looking like we got to use this formula to solve the numerator, and denominator has to be solved using this formula. So let's start this problem. So let's start with this. So we'll write sin x minus sin 3x divided by sin square x minus cos square x. So this is nothing but it's gonna be 2 of cos x plus 3x by 2 into sin of what? Sin of x minus 3x by 2. Alright. And the bottom side we will be getting, this is nothing but minus of cos 2x, the denominator, So the top part will become 2 of cos of 2x into, this is going to be sine of minus of x, and here it will be minus of cos of 2x. So cos of 2x will cancel out, and we also know that sine of minus theta is nothing but minus of sine theta. So we'll use this expression over here. So it will become minus of 2 of sine of x divided by cos of 2x, sorry, cos of 2x is already gone, right? So nothing is left there, right? And we had a negative sign at the bottom, so that will remain as minus 1, and this will become 2 of sin x, which is nothing but RHS, which we had to prove. Alright, so again, like previous example, since the left side is a little more complicated, so we start with this and try to reduce this expression to a more manageable form, which is on the right hand side. So this is how we solve it. Alright, so let's go on to the next problem. What is my next problem? My next problem is having cos 4x plus cos 3x plus cos 2x divided by sin 4x plus sin 3x plus sin 2x. Again here we have to club some of the expressions together, and we got to make use of the formula cos C plus cos D and sin C plus sin D in some manner. This is how it is looking like. And you also got to observe there is some expression in terms of 3x on the right hand side, 3x, right? So we got to retain 3x somehow and then work with it, right? So can we club cos 4x and cos 2x together and use formula cos C plus cos D and sin 4x and sin 2x together to come to formula sin C plus sin D? Why are we doing that? We are doing that because we can see that cos C plus cos D will be nothing but 2 of cos C plus D by 2. So it 4x plus 2x by 2 will become 3x. So looks like we will get some cos 3x over there as well. So that's the reason we are clubbing 4x and 2x together. Alright. So let's do that here. So let's talk about LHS. In a way, I'll put cos 4x plus cos 2x together and cos 3x separately, and use sin 4x plus sin 2x together, and then use sin 3x separately. Alright. Now use formula cos C plus cos D. What is cos C plus cos D? It's nothing but 2 of cos C plus D by 2 into cos of C minus D by 2. And what is sin C plus D? It is 2 of sin of C plus D by 2 into cos of C minus D by 2. So let's use this formula. So here it will become 2 of cos of 4x plus 2x by 2 into cos of 4x minus 2x by 2, and then there is another term cos 3x which will be written just like that, and then we will be having same way 2 of sin of 4x plus 2x by 2 into cos of 4x minus 2x by 2, and then I will have another expression over here which is sin 3x. So now this will become 2 of cos of 4x plus 2x will be 6 divided by 2 will be cos 3x, and this will become cos of 4x minus 2x will be 2x by 2 will be cos x, and then here it will be cos of 3x, and at the denominator again it will be 2 of sin of 4x plus 2x by 2 will be 3x. Why? Because this 4x plus 2x is 6 by 2 is 3x. Same way cos of 4x minus 2x by 2 will be x. Why? Because 4x minus 2x will be 2x divided by 2 will be x, and then I'll have a sin 3x over here. What if I take cos of 3x common at in the numerator? So I'll be left with 2 of cos of x plus 1, and in the denominator I will take sin of 3x as common, and then I will be left with 2 of cos of x plus 1. My 2 of cos x plus 1 will get cancelled out, and I will be left with cos 3x divided by sin 3x, which is nothing but cot of 3x. Alright. So while we were solving this, we started getting a clue over here itself when this was becoming cos 3x that we can take cos 3x common, and in the bottom sin 3x could be taken out common. and whatever will be left out will be cancelled out. Uh, and the first clue was like on the right hand side we had to get cot 3x, so that's the reason we retained cos of 3x in the numerator and then sin of 3x in the denominator, because we wanted to have some expression in terms of 3x itself, right? You could have started with anything. You could have started with cos 4x plus cos 3x also, and eventually you will come to the same expression. But while we choose the expression appropriately, our steps generally becomes less time consuming, and they are generally used to solve the problems quickly. So before solving the problem, just try to observe the expression a little more, and then try to jump into the solution. Alright, so let's move on to the next problem and the last problem for today's lecture. And here we have an expression cot x into cot 2x minus cot 2x into cot 3x and minus cot 3x into cot x, and it is supposedly becoming 1. Alright, so it's a big expression, so something is gonna get cancelled out and then you will eventually get 1. Alright, so another thing to note over here is there is one thing in positive and rest two things are in negative. So something looks like common over here. So what we will do is we'll start with the part which is having negative expression, right? Negative sign. So we'll start here. We'll start here and say LHS, and we'll have cot x into cot of 2x, and then I'll take minus common, then it will become cot of 2x into cot of 3x plus cot of 3x into cot of x. Alright, now again we'll have cot of x into cot of 2x, and can I write this as cos of 2x divided by sin of 2x, and I have cot of 3x twice, right? But let's work with it and then write cos of 3x by sin of 3x plus cos of 3x by sin of 3x. I'm just writing cot x as cot x equals to what? I'm just writing cot x is nothing but cos x by sin x. This is the expression I'm using, and why I'm using it is because I look like if I take something as LCM, I will have some expression to work with. Alright, so that's the reason I'm doing it, and I'll have cos x upon sin x. Alright, now what I'll do is I'll just keep it as it is, cot x into cot 2x, and here since I have cos 3x in both the expression, I just take cos 3x out. Alright, and while taking the LCM, I will have LCM of sin of 2x into sin of 3x into sin of x, right? And here since sin 2x and sin 3x are there, then I will have sin x, and I'll have to multiply it with cos 2x, so cos 2x into sin x, and plus here I have taken out cos 3x common, so I have cos x here, and then here sin x, it is sin 3x actually, sin 3x and sin x are there, then I have to take sin 2x here, so it will be having sin 2x here. So what I did here, again we took the LCM sin 2x, sin 3x and sin x. So when I was doing over here, so sin 2x, sin 3x will cancel out, only sin x will be remaining, so cos 2x will be multiplied by sin x. Here sin 3x and sin x will go, sin 2x will remain, so sin 2x will be multiplied by cos x. Alright, now can you see this expression? This expression is looking a little familiar. It's cos A into sin B plus sin A into cos B, or sin A into cos B plus cos A into sin B, which is a formula of what? It's a formula of sin. It's a formula of what? Sin A plus B. So what is sin A plus B? It will be sin A into cos B plus cos A into sin B. Alright, so here x is A and 2x is B. Alright, so my expression here will be cot x minus cot of 2x minus cos of 3x and this will become sine of x plus 2x, and here I will have sine 2x into sine 3x into sine x. What is my x plus 2x? This will be 3x, so sine 3x and sine 3x will get cancelled out. So I will be so x plus 2x is this, right? So sine 3x will get cancelled out. So I will be left with cot x into cot 2x minus cos of 3x divided by sine of 2x into sine of x. Alright. Now look at cos 3x. We just did a reverse here. Can we do something like this? Can we write cos of 3x as cos of x plus 2x? And can I write this as cos A into cos B minus sin A into sin B? Right? So this is the expression, right? Cos A plus B. Yeah, if you don't remember, just try this. This is gonna be cos A into cos B minus sin A into sin B. Right? So we are gonna use this expression over here. So this is gonna be my cot x into cot 2x. Why I am doing it again? Just to have a look. Here I am having something in x and 2x. This is the only odd term out which is in 3x. So I am just trying to reduce this to something manageable like x and 2x, right? So this is what I did. I just wrote cos 3x as cos x plus 2x, and this is reducing to my cos of x into cos of 2x minus sin of x into sin of 2x, right, and divided by sin of 2x into sin of x. Now if I just keep doing it, cot x into cot 2x and divide this separately, this will be cos of x and sin of x. So this will become cos of x into cos of 2x divided by sin of x into sin of 2x. I just rearranged it, and this will become minus minus plus sin of x into sin of 2x divided by sin of x into sin of 2x. So this will cancel out and it will be 1. Now here this part will become cot of x into cot of 2x, right, and this cos upon sin x will become cot x, and this cos 2x upon sin 2x will become cot 2x, alright, and this expression was 1. Now this and this will get cancelled out and I will be left with 1, which is what I had to prove on the RHS, alright. Okay, so just let's look back at this question again and try to understand what we did. So we were given some expression in terms of cot x 2x, cot 2x, cot 3x, cot x 3x into cot x, and since these two terms were in negative and the only one term was in positive, so we just took this common and tried to reduce it to some form wherein the formula were known to us. So we knew that if we reduce it to cos of A into cos of B or sin of A into sin of B kind of a form, then I will have something to work with. When we did that, we got that something is getting cancelled out, and that happened, and we were again left with this expression at this step wherein it was cos of 3x divided by sin 2x sin x. My rest of the terms were in x and 2x, but somehow this cos 3x was still in terms of 3, rather not in 2 and 1. So I reduced cos 3x again to some form of x and 2x, and thought that something will get cancelled out. This is what was the observation. We were not doing it blindly. We knew that while we do it, this expression is gonna cancel out because eventually we have to have 1, right? So we knew that on the right hand side it was 1, so that's why we proceeded with that. And when we did that, we saw cot x into cot 2x was getting cancelled out and we were left with 1, right? So this is how we did it. It's a little tricky equation, looks like. When you could start with any expression, you could have started with first and second and you still landed on the same result. But in my experience, it looks like that whenever there is some similarity of terms, we should start working with those. Then only we will eventually get to an answer. Alright. So So yeah, that's all for today's lecture. If you have any questions, please ask me in the comment section below and I'll be happy to answer. So thank you so much for watching this video and have a great day. We are going to discuss problem number 23, 24 and 25 of exercise 3.3 and chapter 3rd. So we have already discussed from problem number 1 to 22 in our previous videos. So please go ahead and watch my previous videos to have a look at the solution. So as usual, first we'll start with the concept and then try to solve the problems. So in this problem, we are asked to get the value of tan 4x, and it is looking like an expression on the right side, whatever be that expression. So in my previous videos, I have told you to start with the complicated side of the expression and then work towards the simpler one, right? In this one, I am going to tell you to do the opposite. Why? Because on the right hand side, whatever you are getting is out of some sort of equation which we will try to derive on or rather have a look at, right? So you know that in the book of NCERT, you might have seen a derivation of tan of 2x, alright. So when you look at the derivation of tan of 2x, tan of 2x is nothing but tan of x plus x, and what we do is we actually treat x as a and another x as b, and then we use the formula of tan a plus tan b divided by 1 minus tan a into tan b, alright. And what we do is we just put the values back and we get tan x plus tan x divided by 1 minus tan square x. Again tan x into tan x, rather let's write step by step. So we get a value of 2 tan x and divided by 1 minus tan square x. So this is how we derive the value of tan 2x. We will utilize the same principle to derive the value of tan 4x as well. So what we will do is we will start with LHS and then we'll look at tan 4x. So tan 4x can be written as again tan of 2 of 2x, right? So now let's treat this 2x as capital X or something, right? So we'll use the formula of tan of 2 of capital X. So what will that be? So it will be 2 of tan x divided by 1 minus tan square x, and this is the capital X, this is the capital X, right? So this expression is tan of capital X divided by 1 minus tan of tan square x. Now put back the value of x, so you will be having 2 of tan of 2x divided by 1 minus tan square of 2x. Why? Because my capital X is 2 times small x, that's what I did. And when you look at this 2 times tan of 2x, again I can put back the value of tan 2x, which is nothing but 2 times tan 2x is nothing but 2 times tan of x divided by 1 minus tan square x, and in the bottom I will have same way 1 minus, let's put it like this, tan of 2x, so I'll put 2 of tan x divided by 1 minus tan square x, and the whole thing I'll have to put a square. Why? Because it's a tan square of 2x, right? So that's what I did. Now let's simplify this expression further. So what I'll get is, on the top I'll get 4 of tan x divided by 1 minus tan square x, right? And in the bottom side I'll get 1 minus, again this will be the square, right? So it will become 2 square into tan square x, which is nothing but 4 of tan square x, and then on the denominator side it will become 1 minus tan square x whole square, right? Now again simplify it further, you will add 4 of tan x divided by 1 minus tan square x, and then further I can take 1 minus tan square x whole square as my LCM, and then this will become 1 minus tan square x whole square and minus of 4 of tan square x. So what did I do over here is, first I wrote this tan of 2 into 2x as tan of 2 of capital X, and capital X I said as this is nothing but we assume that 2 of x is capital X, then the expression became 2 of tan x divided by 1 minus tan square x. Why? Because we know the formula of tan of 2x, right? And then further when we simplified and then put back the value of x back, then this became tan 2x. Put the value of x here, tan square 2x, right? And then again you put back the value of tan 2x, and this is what the expression we are getting. So we are further simplifying it, and we have come to this step wherein this is my 1 by tan square x is in the denominator. So what I will do is, there is 1 here in the denominator also, so let's further simplify it, and what it will become is 4 of tan x divided by 1 minus tan square x, and this whole thing will actually become reciprocal of it. That will become 1 minus tan square x whole square divided by what? This will be, let's open this up, this will be, or rather let's keep it like this for one more time, tan square x whole square minus 4 tan square x. Now this 1 minus tan square x and this square will cancel out because this is the square, right? So on the top side we have got 4 of tan x into 1 minus tan square x, and in the denominator I'll open this expression, and because this is a minus b whole square, I'll use the formula a square plus b square minus 2ab. So this will become 1 plus tan square x whole square minus 2 times tan square of x, and then I have another 4 of tan square x as well. Now what will this expression become? This expression will become 4 of tan x into 1 minus tan square x, and the denominator I have 1 plus this tan square x, and then I'll further square, this will become tan to the power 4x, and I have minus 2 tan square x and minus 4 tan square x, which is minus 6 of tan square x, right? So let's look back the expression what we were supposed to prove, and when you look at it, you've got 4 tan x minus 1 minus tan square x, and then the denominator has been rearranged, and you've got the denominator is nicely rearranged, and we have got 4 of tan x into 1 minus tan square x divided by 1 minus 6 tan square x plus tan to the power 4x, right? And this is what we had to prove on the RHS side, and this is proved. So we got to just use the formula of tan 2x 2 times to actually get this value. This is all we had to do. It's just that the calculation is a little lengthy, but you will eventually get this expression. Alright, so let's move on to the next problem. Our next problem is this one. In this one, again, just like tan 4x, we have to prove cos 4x is equal to some expression. So we'll do the same steps again. We'll first try to remember what is my cos 2x. My cos 2x was nothing but there were 3 formulas actually. One was cos square x minus sin square x. Then there was 2 cos square x minus 1. And then there was another one which was 1 minus 2 of sin square x. So we'll use one of these formulas. As we can see that it's an expression having 1 minus 1 minus 8 sin square x cos square x. So maybe what we can do is we'll start with something which is having cos square or sin square. We could start with this, or we can start with this. Alright. So since it's 1 minus something, I tend to believe that we should start with this. Alright. So let's start with this. So what is to be done is we will assume, to avoid confusion, 2x equals to a. Assume. Let's assume 2x equals to a. So my left hand expression becomes what? Cos of 2a, and cos of 2a in terms of sin is 1 minus 2 sin square a. Now again here let's put back the value. So 1 minus 2 of sin a is nothing but it's a sine of 2x, a equals to x, and the whole thing here is the square of it. Alright. We also know the value of sine of 2x. Sine of 2x is 2 of sin x into cos x, right? So we will use this formula, 1 minus 2 of this, and then sine 2 of x is 2 of sin x into cos of x, and the whole thing square. So this will become 1 minus 2 into, this will become 4 of sin square x into cos square x, right? This will become 1 minus 8 of sin square x into cos square x, and this is what we were supposed to prove on the right hand side. Alright. So here we will write since 2x equals to a, right? So this one, all we had to figure out is which of the formula of cos 2x we should be using, and while looking at the expression we realize that maybe the third formula will make our job a little easier. It's not that if you had started with this one you will not get the result. You will get the result. It's just that there will be a couple of more steps to be done. Alright. So we are done with the second problem. Let's do the third problem of the day. So what is our third problem of the day? There is a problem here. Here it is talking about cos of 6x, and then there is a huge expression on the right hand side. So again, if you look at 6x, right, 6x can be written as like 2 into 3x or 3 into 2x. It can be written as this or this, right? So my cos of 6x I'll use either this or that, right? And then I have to know two formula as well. So one we know already, cos of 2x, which is nothing but cos square x minus sin square x, as we did in the last one. And then we also need to know the formula of cos of 3x, because either it is gonna be not 3 or either it is gonna be 2, right? So we'll use one of these. So we'll say cos of 3x will be 4 of cos cube x minus 3 cos square x. There is a formula. We can derive this formula. How do you derive this formula? You can write cos 3x is equals to cos of x plus 2x, and then use the formula of cos a plus b, and then you will be able to derive this result also. So I am not going to derive this result right now, rather I will be making use of this results. So LHS is my cos of 6x. Alright. So one of these I will be using. So let's use cos of 3 and then call it 2x. So if my 2x is, I am assuming now, let's assume 2x equals to a, then this will become cos of 3a. When this becomes cos of 3a, I can write it as 4 of cos cube a minus 3 cos a, right? Once I got this, I can as well write 4 of cos of cube of 2x minus 3 of cos of 2x, since 2x equals to a, right? Now look at this expression. We have got cos cube x and cos 2x. And when I look at on right hand side, I can see everything in cos. So instead of using this formula cos of 2x cos square x minus sin square x, I am inclined to use this formula, which is called 2 cos square x minus 1. If I use this formula, then everything will be in cos. As I said earlier, I can either make use of this formula or the other one, it doesn't matter, alright. So anything is fine, but let's use the formula of 2 cos square x minus 1. So 2 cos square x minus 1, I just put the value of cos 2x, but this whole thing has a cube on it. So I'll just put this cube, and then minus 3 of cos of 2x will become what? It will become, this will become 3 into cos of 2x is 2 cos square x minus 1, right. Now my expression 2 cos square x minus 1 to the power whole cube. I also know a formula. We have to make use of a formula which is a minus b whole cube, and this is nothing but a cube minus b cube minus 3ab a plus b. Alright, and here my expression, if this becomes my a and this becomes b, it's nothing but a minus b whole cube, right. So I'll be using the formula here. So it's a cube, so it's 2 cos square x whole thing cube, then b cube minus 1 to the power cube, then I have to use 3 into ab, 3 into 2 cos square x is a and b is 1, and then I have to use a minus b, so 2 cos square x minus 1. So this is my expression, right. And now the other thing I have to also write, this is 3 into 2, I have to expand that, this is nothing but 6 cos square x and minus 3 and plus 1, this will minus 1 will become plus 3, right. Now this expression 2 to the power 3, this will become a, and cos squared x to the power 3, this will become cos to the power 6x minus 1 cube is 1, and then again 3 into 2 is 6 cos square x, 6 cos square x into 2 will be 12, and then there is further cos square x, so this will become 12 of cos to the power 4x, and then multiply this with this, there will be minus 3 into 2 6 cos square x, and this is minus 1 and this is minus 1, so minus 3 into minus 1 will be plus, so then this will be 3 into 2 6 of cos square x. Now I have to still write this expression which is minus 6 of cos square x plus 3, alright. Now there is a 4 outside, let's multiply it, so this will become my 32 cos to the power 6x minus 4, because 4 into minus 1 minus 4, then there is 48, 12 into 4 48 cos to the power 4x, and then there is a 24 cos to the cos square x, and then I have minus 6 cos square x, and then I have plus 3, alright. Now let's again rearrange it a little better. What I will have is 32 to the power cos of 6x, then the next highest power which is 4, so this will be minus 48 times cos to the power 4x, then my highest power is cos square, 24 minus 6, this will be 18 cos square x, then I have minus 4 and then plus 3, this will be minus 1, alright. Let's see if I have made any mistake in calculation, otherwise this is what we have to prove on the right side. So 32 cos to the power 6x minus 48 cos to the power 4x plus 18 cos square x minus 1 is what we have to prove on the right hand side. Yeah, so this is what we had to prove on the right hand side, and this is proof. So in today's exercise, all three problems were dealing with using the expression of either cos 2x, cos 3x, tan 2x, or cos 2x and things like that. And all we had to do was just to make use of the formula. If we remember, if we don't remember, we just go back to the basic and then try to derive the formula. Everything is being derived from cos A plus B, which we had actually derived in the very first exercise itself. So hope the problems are clear to you. If not, please ask me in the comment section below and I'll be happy to answer. Thank you for watching this video. Have a nice day.